As Mercury's portrait continued to sharpen, thanks to the wealth of data from the MESSENGER mission, yet another layer of the planet's enigma was uncovered, its surprisingly active interior. Scientists had long assumed that such a small world so close to the Sun would have lost all its internal heat billions of years ago. Like Mars, Mercury should have cooled quickly, solidifying its core and ending any geological activity. But Infinity Beyond and planetary scientists across the globe were about to learn that Mercury had defied those expectations too. One of the most intriguing surprises was Mercury's magnetic field. Earth's magnetic field is generated by a dynamo effect. The movement of molten iron in its outer core produces electric currents, which generate magnetism. For Mercury to have a magnetic field, it must still possess a partially molten moving core. And indeed, MESSENGER confirmed this through careful measurements of gravitational and magnetic variations across the planet's surface. The results were astonishing. Mercury doesn't just have a core, it has a complex, multi-layered one. Beneath its solid silicate crust and mantle lies a solid shell of iron sulfide, which itself surrounds a liquid outer core and possibly even a solid inner core. This kind of internal structure was previously thought to exist only in much larger planets. That Mercury, the smallest rocky planet in the solar system, retains such an active and layered interior was a radical departure from expectations. The existence of a magnetic field was just one piece of the puzzle. MESSENGER also recorded its unusual shape. Unlike Earth's field, which is relatively centered, Mercury's magnetic field is offset, shifted significantly to the north. This lopsidedness remains poorly understood, but points to highly unusual and uneven convection within the core. It may also be tied to asymmetries in Mercury's crust and mantle, or residual effects from that ancient cataclysmic collision. What this revealed to scientists at Infinity Beyond is that Mercury is not a geologically dead world. Far from it. While it lacks the plate tectonics or eruptive volcanoes of Earth, the interior processes that power magnetic activity and possibly slow geological reshaping are still ongoing. This realization places Mercury in a unique position among the rocky planets, part relic of the past, part dynamic system. In tandem with this discovery was a deepening appreciation of how Mercury's layered structure might have formed. As the young solar system settled into its final arrangement, Mercury found itself subjected to incredible forces: collisions, solar radiation, tidal stress, and orbital perturbations. These forces not only altered its orbit, but also influenced how heat moved through its interior, possibly preserving a liquid layer longer than previously imagined. Understanding how Mercury's core remains molten despite its small size has led researchers to propose several theories. One posits that radioactive elements trapped deep within the planet during its formation continue to release heat. Another suggests that tidal flexing caused by its close orbit around the Sun contributes enough mechanical energy to keep parts of the core fluid. Either way, the presence of a functioning magnetic field and a layered interior makes Mercury one of the most unexpected members of the solar system's inner circle. At Infinity Beyond, Mercury's strange magnetism and enduring dynamism are reminders that our assumptions about planets, based on size, distance, or even past models, must always remain flexible in the face of new evidence. Mercury defies easy categorization. It's a planet that should be quiet, cold, and still, but instead it pulses with the legacy of a violent past and the whisper of ongoing internal power. Mercury's bizarre structure, its massive iron core, lopsided magnetic field, and unexpectedly dynamic interior can't be fully understood without examining the early environment in which it formed. About 4.5 billion years ago, the inner solar system was not the calm, orderly place we see today. It was a chaotic battlefield of planetary embryos, rocky debris, and competing gravitational forces. In this primordial arena, only a few worlds would emerge intact. Mercury was among the survivors, but not without paying a heavy price. The story begins in the protoplanetary disk, a swirling, dusty plain around the young sun where particles collided, clumped together, and gradually grew into full-fledged planets. At that time, space was thick with fragments of rock and metal, some no larger than grains of sand, others the size of small moons. These planetesimals repeatedly collided and merged, forming larger and larger bodies. But this process was anything but smooth. Mercury's formation was deeply entangled in this early violence. Scientists now believe that Mercury did not accrete smoothly from dust and rock like Earth. Instead, it likely endured at least one titanic collision, a catastrophic impact that not only shaped its orbit but stripped away much of its original outer layers. This collision may have blasted away Mercury's silicate mantle, leaving behind the iron-rich core we see today. In the wake of such a tremendous impact, the resulting debris would have been scattered into space or reaccreted onto other planets. Data from the MESSENGER mission and models examined by the Infinity Beyond team strongly support this scenario. The absence of a thick mantle and the planet's unusually high metal-to-silicate ratio are difficult to explain otherwise. This so-called mantle stripping hypothesis not only accounts for Mercury's enormous core, but also provides a compelling framework for understanding its unusual chemical composition. But this theory raises another question. What happened next? How did Mercury settle into its current orbit, the innermost of all planets? To answer that, we need to consider the gravitational influence of the solar system's biggest bully, Jupiter. During the early migration of the giant planets, Jupiter is thought to have moved inward from its original position before shifting back outward, a process known as the Grand Tack hypothesis. As it moved, Jupiter's immense gravity would have disrupted the orbits of the inner planets, scattering material and reshuffling the layout of the early solar system. Mercury, small and light compared to the growing gas giants, may have been caught in this gravitational turmoil. Flung inward by Jupiter's influence and destabilized by its earlier collisions, Mercury could have been pushed into its current sun-scorched orbit. Once there, it became locked in a precarious dance, spiraling around the sun on the most eccentric path of any planet, scorched on one side and frozen on the other. This tumultuous journey left Mercury permanently scarred, not only physically but dynamically. Its highly elliptical orbit causes intense solar heating on its perihelion side, while the lack of atmosphere allows temperatures to plummet dramatically during the long night. The resulting stress on the planet's surface contributes to massive faults and escarpments, still visible today. At Infinity Beyond, the tale of Mercury is more than just a planetary origin story. It is a vivid reminder that the solar system we see now is the result of unimaginable destruction and randomness. Mercury is the battered core of a world that could have been very different, a world that perhaps once had oceans, an atmosphere, and the potential to support life. Instead, it was reshaped by cosmic violence into a metallic ember, circling the sun like a silent witness to the chaos of creation.